Support for KQED Live comes from Berkeley Rep.
Support for KQED comes from the Asian Art Museum. Visitors can step into an experience like no other at TeamLab Continuity and become part of a wondrous ecosystem of lush natural imagery that dynamically evolves around them. For more information and ticket reservations, visit asianart.org.
The disproportionate impact of
more than half of Black business owners.
And disproportionate.
Somehow we always find a way to rise.
To the blueprint builders, to the backbones of every block, for the curators of the culture, and for generations to follow. You might fall, but never fail. Keep rising, keep rising, keep rising. Apply for business, marketing, and tech makeovers on us.
So glad I'm flying out of Oakland today. Let's count the reasons why. For one, flying locally reduces my carbon footprint. Plus, my airport supports over 17,000 jobs in the East Bay. And it makes sense. The more I fly from OAK, the more flights airlines will add out of OAK. All good.
No matter where you live in the Bay Area, there are many great reasons to pick OAK and fly the East Bay way. What you do with that extra hour is up to you.
Hi, everybody. Good evening, and welcome to KQED Live. I'm Ryan Davis, the Executive Director at KQED Live, which is a new multi-platform event series that's dedicated to bringing KQED's mission to inform, inspire, and involve to life on stage through journalism, through performances, conversations, storytelling, screenings, food tastings, and much more. I would like to begin tonight by making a land acknowledgement. Here at KQED's headquarters in the Mission, we're located on the occupied lands of the indigenous Ramaytush Ohlone people. To honor both the land and the people who have stewarded it for thousands of years, we acknowledge the history of genocide and forced removal of the original inhabitants of this territory. We also honor and respect those many indigenous people still connected to the land here. And I hope you'll consider this as a part of the reflection on how we all find ourselves here in this place at this moment together. Tonight's program is about some of the creatures who share this land with us. Deep Look is an Ivans, who we'll meet in a moment. But first, we'd like to thank the season sponsors who make KQED Live possible. They are Asian Art Museum, Berkeley Rep, Comcast Business, and Oakland International Airport. And we're grateful for their commitment to supporting civic and cultural engagement in the Bay Area. And I want to thank all of you for joining us tonight. Once I'm done up here, I'll remain fully masked throughout the evening, and we ask that you do so as well if you're here in person. And for all of those of you who are joining us online on YouTube at KQED and Deep Look's pages, we hope to see you here sometime soon. So if you like what you learned here, or if you're looking for what else we've got going on, please pay a visit to kqed.org/live to find out more. Okay, now it is my great, great pleasure to bring out our host this evening, Laura Clivens.
Thank you, Ryan. Hey, everyone, and welcome to our Deep Look Creepy Crawly evening. This is a real pleasure for us because this is our first live event since the start of the pandemic, so we're all very excited. You'll see me getting like really worked up over here because I'm very stimulated by other people, an extrovert. So thank you so much. And we also are here to celebrate our new event space, which is an awesome opportunity to connect with the community, which is what we're here to do. So also, we are filming this, and we have a lot of people joining us online. For our Deep Look fans watching on YouTube, many thanks for joining us there as well. I'm Laura Clivens, as Ryan mentioned. I am a KQED climate reporter, and I'm the host of Deep Look. And Deep Look is KQED's Webby and Emmy award-winning online wildlife series exploring tiny worlds up close in 4K resolution. And for those of you who don't know yet, KQED We are the San Francisco Bay Area's member-supported PBS and NPR station, and we rely on support from people like you to make the series that we make here, like Deep Look. We provide our community with independent reporting, and we do that through television, radio, online programming that aims to inform, inspire, and involve you all. You can find out more at kqed.org. So we have a little intro for you here, and then we'll get to watching some of these videos. You can also check out our full collection of Deep Look videos at kqed.org/deeplook and subscribe to our channel on YouTube, KQED Deep Look. In fact, if you are watching live on YouTube right now, please click the subscribe button and tap the notification bell icon to get updates on all our latest episodes. Becoming a YouTube subscriber really helps to support us so we can continue bringing you these amazing videos that bring us deep into the realms of all these little worlds. Since 2014, we've produced almost 150 videos, and we have more than 1.8 million subscribers and 340 million video views. So a quick shout out to all of our super fans, our deep peeps, as we like to call you. Thanks so much for watching. Yeah, hope some of you are here. We also want to say a special thanks to all of our patrons on Patreon. You can go behind the scenes with our team and support us at patreon.com/deeplook. Well, we have an awesome program for you tonight. You'll learn about the turret spider's tiny tower of terror. You'll see how ticks dig into skin with a mouth full of hooks, pretty creepy. You'll witness the scorpion's lightning-fast stinger and also see the unusual softer side. That helps them figure out who's a menace, meal, or a mate. And we have a bonus episode for you about pallet bats and how they hunt a lot like vampires, plucking their prey from the ground in the final moments of their attack. You'll also meet our producers and hear from special guests. And those are the scientists and naturalists who study these creatures and help us with our episodes. So it's pretty awesome to have them all here. We also have some extra tricks and treats for you too. We'll do a live macro cinematography demo. We'll show you how we film these unique animals. And for those of you here in person, you'll get to meet bats, scorpions, spiders, and ticks up close in our lobby after the screening. Perhaps you saw some of them as you came in. We also want to hear from you. So you've all received cards. As we are going through this, please write down any questions you have on those cards. And one of my colleagues, Lance, will be in the middle aisle, and he will come through and collect those questions. You can pass them his way, and we will pose them to the folks up here. For those of you watching on YouTube, we want to hear from you too. So be sure to put your questions in the chat, and we'll do our best to answer as many as we can. Speaking of the chat, we're trying something new. We've enabled YouTube Super Chat and Super Stickers tonight. If those of you joining us online would like to show some extra big love and support for KQED in Deep Look. So who is ready to be creeped out? Yeah! This is a great Halloween intro. Okay, so let's watch our turret spider video first, and then we will talk after the video. Enjoy.
The world is a very different place when darkness falls. Most of us head for home, for cover, because as the shadows creep in, they hide things, frightful things. What is that? That little tower? Look, there's another one. They blend in so well. That was a California turret spider. Its lair is like the turret of a castle, rising above the forest floor. It's lined the inside with pearly white silk and coated the outside with mud, moss, or leaves. The turret leads down to the spider's burrow that can descend 6 inches underground. The spider spends its days down there. As the last rays of the sun die out, it rises. To wait, motionless, until some unsuspecting creature happens by, like this pill bug. Every step it takes creates tiny tremors, betraying its location. Whew, that was close. Turret spiders actually have pretty poor vision. Instead, they rely on feel, bursting out in whichever direction the vibrations seem to come from. So sometimes they miss. They belong to a group of spiders called megalomorphs, along with their more famous cousins, tarantulas and trapdoor spiders. They pack oversized fangs that swing down like a pair of pickaxes. They were hunting this way long before spiders started building intricate aerial webs, like this orb weaver spider. Instead, a female turret spider might live for 16 years and never stray from her turret. She only ventures into the world for a split second, just long enough to drag her next victim down to its demise.
Ready to go for a hike in the woods? So we're gonna bring out some of the people behind this video. So come on out here. We've got Josh Cassidy. He's the lead producer and cinematographer of Deep Look. He's won numerous cinematography and producing awards. In fact, he recently won a Jackson Wild Media Award for his stunning episode on aphids. Congratulations for that, Josh. So here's Josh.
All right. Hello, everyone.
Josh goes above and beyond to make our films. So here's some things that he's done. He has scuba dived in cold water to film live sand dollars. He has been locked in a pitch black room with bats. You'll see some of the spooky footage he got later in the show. And Josh got his bachelor's in wildlife biology from Ohio State University and has participated in marine mammal research. He also studied science and natural history filmmaking at Montana State University. And then also with us is Trent Pearce. He's been both learning and teaching California natural history for 15 years. He's an interpretive naturalist with the East Bay Regional Park District who leads guided walks, gives lectures, creates educational posters, panels, videos, and tries to satisfy the burning question of so what for the general public. He has a degree in forestry and recreation from the University of Tennessee. So now that you know who our wonderful guests are, if you do have any questions about this last video, feel free to write them on the card. If you are here live with us, if you are joining us online, put those questions right into the chat. All right, I'm gonna kick it to you, Josh, and you can ask some questions to kick us off.
All right. So Trent, how did you first find out about turret spiders?
Well, I was an environmental educator down in the Santa Cruz Mountains, and I led 5th and 6th graders on guided walks. And my students actually would spot them, these little castles on the sides of the trail, often under redwoods. And they're like, what are these things? And I was like, I don't know. It turns out they were turret spiders.
Cool. Have you ever heard of anybody getting bit? I mean, they jump out. They're pretty startling. They've startled me before, I'll admit. But have you ever heard of anybody getting bit by them or anything?
I mean, given that they spend almost their entire lifetimes in their burrows, I think it would be really difficult to get bitten by one. Maybe if you were a turret spider researcher handling them a lot. But no, I've never heard of anyone getting bitten by one. I did just find a TikTok account in which someone holds spiders and intentionally gets them to bite their fingers. And they theoretically had one of a turret spider doing that. I'm not sure if it was identified correctly, but yeah. Other than that, no.
So we talked a little bit about their fangs in the episode, but they're different than a lot of the spiders that you find like that maybe spins a web in your backyard, something like that.
They are, so they're megalomorphs, which are a group of spiders that come from a more primitive lineage. So the two kinds of spiders, well, we have three kinds of spiders in the world today. The mesothelids, which are really bizarre, strange. The megalomorphs, like turret spiders and tarantulas, and the araneomorphs, which are the classic orb-weaving spiders. And of those three, the mesothelids and the megalomorphs share the sort of body form of their last common ancestor. So essentially, turret spiders have been doing what they're doing for a really long time, and it's the araneomorphs that are sort of the new kids on the block. Those downward-facing fangs allow them to trap prey against the ground or against the edge of their turret, as you saw in the video, and inject venom.
As opposed to the other one?
Right, as opposed to araneomorphs have sideways-facing fangs, like a pair of scissors, which allow them to trap prey in the air and inject it with venom.
Cool.
That's awesome. Yeah. So we've got some great questions coming in from our audience online. And again, for those of you here, feel free to write down any questions and pass them to the center, and Lance can grab those for us. So this question comes from Marlon. How far do baby turret spiders travel to build their next turret?
Not far. Essentially, as soon as they disperse from the turret, they're really vulnerable, both to being eaten but also to drying out. And so they disperse as far as they have to be able to find suitable habitat. And they usually start with a pre-existing crack in the ground or a little hole that they'll occupy, lined with silk, build the turret on top, and that becomes their home. So what this causes is these colonies of turret spiders, because they don't disperse very far from their natal burrow, you get like a hillside that will be covered with turrets, and they'll be of all different sizes, and that indicates the different age classes of spiders.
Yeah, we saw that at the end of the episode. We saw the sort of bigger turret with, I assume, the mother in there, and then a little smaller neighboring one, just moved down the street.
Right, probably a relative.
That's pretty awesome. Okay, our next question also comes from online, from Katie. Are turret spider eggs laid inside the turret, or does the female carry them on her body?
They're laid at the bottom of the turret and protected with a layer of silk, and then they hatch out and sort of, again, slowly disperse up the turret and out when they're kind of old enough to be out on their own. And I think there was footage of that at the end of the episode.
Yeah, there was.
So I learned that answer because I watched the episode.
I also thought it was so cool how the outside is so camouflaged with just whatever is there, but the inside is that like really like clean white silk. It looks like, I don't know, like a silk shirt or something.
I know, it looks kind of
And the outside is so rugged,
They keep a clean house.
Yeah. I was surprised also by how soft the turret was. I thought it would be like totally solid, but because of that structure, it seems to be a little flexible.
Mm-hmm. Yeah. Right, you can kind of see that in the episode too. Okay, so this is a question from our live studio audience. What's up with male turret spiders?
What's up with male turret spiders? Well, do you want to be more specific?
Well, can you tell us a little bit? I mean,
yeah. So
we could hear from the audience, but also, I mean, is there a difference between male and female? Like, are the ones that we're seeing both of them, or
there are in most spiders, males have a different set of pedipalps. So you've probably been told your entire life that spiders have 8 legs. They actually kind of have 10. It's just that we have different terminology for the 2 short ones that are right next to their face. We call those pedipalps. And in most spider species, the pedipalps, the ends of the pedipalps are modified to carry sperm. and deliver it to the female for mating. So that's one difference between males and females. Female spiders also tend to be larger. They have a bigger abdomen because they have to house that egg-laying equipment inside. And female spiders, female megalomorphs, tend to live much longer than males. So male turret spiders live around 8 or 9 years. These are rough numbers because these actually haven't been studied a lot in great detail, but around 8 or 9 years before they leave their burrow and go and search for a mate, and then they mate and die. That's it. Females, you heard that, up to 16 years in the video, and that's a rough estimate based on a study from the early 90s. But so the males are much more short-lived than the females.
And then I believe the males at some point need to venture out and to go find a mate.
Yeah. After 8 or 9 years, they leave their burrow and they, go out wandering. Lots of megalomorph spiders do this. Tarantulas do the same thing. So they leave the comfort of their burrow that they've known their entire lives and go smelling for a mate, essentially.
And then I would think getting in through the front door is a dangerous proposition. They're sort of waiting for.
That's challenging in a lot of animals.
Yeah, exactly.
Maybe humans as well. This question is from our audience here, from someone named Arcadia. How did you get the video of inside the tunnel?
So we just got one shot of that because we found that it was hard to do that. We try not to damage anything, and so that was very hard to do. That was actually with a producer who used to work on Deep Look, Elliot Kennerson. He took a little boroscope, like the little camera on a cable that you might stick down your drain to find the wedding ring that's
like tiny
lost in the sink, So he used one of those and just stuck it right down in that little hole, and you can see that the turret spider is not super pumped about it.
All right, so the question comes from online, from Ian Alexander. How much time does it take for a turret spider to build their turret?
Their entire life. Because as soon as they disperse from their natal turret, they immediately build their own burrow and construct a really tiny turret at the top. And then as they grow, they're constantly excavating and enlarging that burrow and then working on the turret. So, from the time that they disperse until they are finished with their life, potentially up to 16 years.
So is a turret that's been worked on for 16 years substantially larger than the others?
Oh, yeah.
How big do they get?
Maybe as big as your thumb. Yeah.
It's so hard because, like in the Deep Look videos, right, we're looking at them and we think they're all so huge. And then we hear that that's the largest size of a turret.
That has an effect when you're filming. We did this in the park at night. It is a totally moonless night, and got the macro lens zoomed in on the turret, and then you saw we kind of tickle the side of the turret to get them to come out. And when you're really zoomed in there and it comes out and it's terrifying. We didn't include it in there, but there's one clip that we have where I was filming and I was tickling it with the little leaf, and then it just comes out just furious, and I didn't scream. I did not scream, but I did run. And I was like, you hear it on the camera, me go, ugh. And then and then I'm like, oh wait, they never go more than that far away from their turrets, but I can stop running. Yeah.
It was really.
And then there's the sound of them laughing at me.
I mean, I've heard that clip, and it sounded like a scream.
It was just a rapid exhale.
Okay, yeah. Sure. Okay, the next question is from online, from Fishy. What's the biggest insect a turret spider can catch?
Ooh, a superlative question. I would say the size of its burrow. It's not going to destroy its burrow or the turret to pull prey down into it. So, it has to be small enough that the spider can physically grab it and inject it with venom and then fit down into the turret and into the burrow underneath the turret. So the larger the spider, the larger the prey item it could catch. Again, the biggest burrows that I've seen are, about the size of my thumb or a little bit bigger. So if you imagine the end of my thumb or maybe your thumb, about that big.
So what kind of insects would that be?
Lots of beetles, roly-polies, insects that crawl around on the ground at night.
they seem particularly strong. Maybe I'm just making this up, but they seem stronger than the types of spiders you see, with webs.
Yeah. The megalomorphs in general rely on a combination of kind of power and then venom to overwhelm their prey. So they kind of tackle it and then inject it with venom, which we all saw. Did anyone jump when it came out?
Yeah.
Yeah. See, you're not alone.
Okay, another question from online, from Thomas R. How tough are their mandibles, and can they pierce through exoskeleton?
Yes, by mandibles, I'm guessing we mean fangs. So the fangs are attached to the chelicera, and those are you can see it in on the screen right here, those kind of big hairy things that are on the front of the face. So those act as sort of fang shields. The fangs are on the back side of those, and they flip down and then open up and pierce. And they're very tough. I mean, they're, tough enough to pierce through the exoskeletons of any of their prey items. Otherwise, they wouldn't work.
Yeah.
That's across the board for spiders too, though. So in web-building spiders, the araneomorphs, they tend to have much smaller fangs, and they capture smaller and more delicate prey like flies and moths and things. But these ground-dwelling spiders have really robust equipment for, grabbing and stabbing their prey.
Nice.
Cool. Okay, so we have another question from our audience. And so this question is not necessarily about these spiders, but it is about something else that appears in the video, the pill bug. Let's see if either of you can take this one. It's okay if not. I heard they are not bugs, this person asks.
It's true. Yeah, pill bugs are not bugs. They're isopods.
What's an isopod?
It means they taste like shrimp.
Yeah, it means they taste like shrimp. An isopod is a multi-body segmented animal with many legs, more than 8.
And they taste like shrimp.
And
if you're curious,
you want to tell us more about that?
There's actually a Deep Look episode about them, which we worked together on years ago. Yeah, they have a really interesting way of breathing, which is more like the shrimp in the ocean compared to like bugs on land that have the trachea system that would have air come in. They basically have, I believe it's book gills that sort of resemble more like what aquatic animals would use to breathe. So, but I have heard that I don't recommend it, and I have not tried it personally, but I've heard that instead of tasting like a cricket or something, they would taste like shrimp.
Trent, have you tried it?
I have not tasted any pill bugs.
Interesting.
Yeah, check out the episode.
Yeah, that is a good episode. All right, we have another question from online, from the Random Assassin. What type of landscapes can you find turret spiders in?
So turret spiders are a California endemic. They range from around the Oregon coast down to around Monterey in terms of north-south. Then they're in both the Coast Ranges and the Sierra foothills. And in those areas, in that range, they're found in forested habitats, usually under trees. And then where I personally tend to find them are kind of in ravines or gullies or on slopes in areas that have a little bit of shelter. So think of like on a slope next to a creek, under a log, or under like a little bit of a dirt overhang. That's where they tend to build their turrets. And
sort of on like sloped ground.
Yeah.
Cool.
Yeah.
All right, well, thanks. So we have another awesome segment for you right now. This is something we weren't able to do during the pandemic, so I'm really glad we can do this right now. We are going to show you the magic of Josh Cassidy as he films. And so we have the setup over here on the side. And so Josh, hopefully you can describe to us a bit about what it is that you do to make your magic happen. And then Trent, it would be really helpful if you can come along in case we need help wrangling one of these animals over there. So yeah, let's all get up and head over there. And Josh, will you tell us?
Yeah, hopefully this won't go horribly awry. So we have a scorpion in here. And actually, if you look under your seat, there's scorpions for everybody. We actually have some pretty docile scorpions. I'm going to adjust my exposure here, around here, and get my focus. Is everybody getting that? All right, cool.
Wow.
You awake?
Oh.
Yeah. So we wanted to show you one of the ways to find scorpions in the wild is to use a black light. we were going to show you an example of this fluorescence. So why don't you hit that? I'm going to cut this light out.
So what does that mean when it actually, to fluoresce? It means this.
So fluorescence is this animal has an exoskeleton, and its exoskeleton is absorbing light at one wavelength and reflecting it at another, and thereby giving us this really crazy bright coloration. It's not bioluminescence. That would be if it glowed on its own. So this takes light. But any blacklight flashlight will do this.
So this is how you would find them at night?
Yeah, this is how I found this one at night.
Mm-hmm.
Wow.
Yeah.
And then Josh, can you describe some of the things that you're actually doing with your camera and a few details about the camera as well?
Cool, yeah. So for macro, the really important part isn't so much the camera, it's the lens. So this is a macro lens from Canon, but there's several different types. And it's able to allow you to get very close to animals, or anything, really, your subjects, and have it stay in focus. A lot of like regular lenses, if you get them very close to something, they can't get focused that way. So I have a variety of different macro lenses. This one is sort of the prettiest, I would say, and the easiest to use, but there's other ones that zoom in more. So you'll see in Deep Look, this is sort of the shots that sort of set the scene and introduce the animal, and then I have a couple other ones that will zoom in quite a bit farther, but they are a lot harder to use, and I didn't want to do it in front of an audience. But yeah, here we can switch the light back on.
And so you mentioned about the light, what's significant? How is this different than filming something that is not quite so close up?
Yeah, with macro, you need a ton of light. And we're very fortunate in the Bay Area because we have overcast skies a lot, and that makes a really nice even light, which I like for shooting. But if that's not an option, or filming at night, there we go. I didn't scream. That was good. All right, now I'm gonna scream. No. Anyway, so if that's not an option, it just went right under that bark. If that's not an option, LED light is fantastic because it doesn't usually make hot. Like the light itself isn't warm. Old sort of incandescent lights, they would just cook our subjects. So
be a bad look.
LED is nice. This is just a really powerful light because you're just filming something very small. It means that light has to bounce off of that small thing, as opposed to if you take a wide shot of a vista or something like that. There's all the light bouncing off the whole scene. For this, we have to bounce a lot of light off of something very small in order to get the right exposure. So, hello.
So this looks huge to us, looking at it here. How big is this scorpion that you're actually looking at here?
Yeah, I don't know, maybe a little shorter than my pinky.
From the head to the
from the head to the end of the tail. But yeah, so there's a lot of either not all of the subjects are so cooperative and will hold still. So there's a lot of like predicting where they're going to go. So for example, I might focus here and then expect and wait for it to start moving, and then eventually it'll start, this one's taking a little coaxing, but so you can kind of predict where they might go. A lot of animals, for example, like dragonflies, seems like they would be hard to film, but they'll keep returning to the same perch over and over. So there's sort of little tricks like that you learn over time that makes it easier to film. But the hardest part is catching focus, which is sort of what I just did right there. With these macro lenses and with tiny animals, the amount that's in focus, the depth of field, is like super, a millimeter or maybe a little bit more or less. So it's very easy to have things go out of focus. One of the tricks I do is to always focus on sort of the closest part to me and let, for example, the back go out of focus there, because it's hard to get everything in focus at the same time. This is another challenge, is that the ground is a little shaky. And this happens a lot when you're so zoomed in that even just putting your hand on the camera or you shift your feet, and it ruins the image. So it takes a lot of patience.
What would you say is the ideal size of something to film for a Deep Look episode?
I'd say like a newt.
A what?
A newt.
Okay.
A salamander or something. That way I can zoom in on, because the smallest things are like a flea, you know, and it's hard to get just the flea's eye. But with a newt, also they got like kind of a smile, so it makes it more charismatic. I found that this is actually a challenge with scorpions, is to figure out exactly where their face is. Because that's basically it, you know. You can see their eyes and stuff, but something with a smile I like, so like a frog or a newt. But really, I'm pretty up for whatever, yeah.
Cool. And then our deep look episodes end up being anywhere from 3 to 5 minutes. And so I'm curious if you could tell folks, you know, how much, so we whittle down footage from around how much? How many hours?
Hours and hours. It depends on the shoots. Sometimes you have to set up a shot and then wait for the behavior, and the camera's just recording that whole time. So then we'll end up with a ton of footage to get a few cool moments. Like, for example, those turret spiders, you might just wait and wait and wait for something to happen. Others are, you know, more predictable, and you can have it sort of be a higher ratio of usable footage in there. But hours, I would say 2 to 4 hours, basically, of footage to get a 3-minute piece. And that's usually 2 to 3 days of filming. Long days, yes.
Cool.
Yeah.
All right, great. Anything else you wanna add? Any gems for folks who are interested in this kind of work?
Interested in this work, yeah. It's a tough one. I find that you can sort of work on somebody else's project, or you can work on your own smaller project. And I ended up in the beginning doing a little of both. I made my own films, so I got to have full control and sort of grow and learn that. But also I worked on other people's bigger productions where I could learn from them and have people hand down information. So that's sort of my advice for people seeking it out as a career, is to do both your own projects and somebody else's, your larger projects, and then never to have there be any task that's too big or small. I got plenty of coffee for people before I got into the exclusive world of filming scorpions.
Well, thank you both so much, and thank you. Don't know what your name is, but graduate, has a degree in psychology.
Yeah, it's very private.
Yeah. All right, well, thank you both so much.
Yeah.
We're gonna go onto our next video while they wrap up. So now hopefully you'll appreciate even more what it is that we're seeing now that we've pulled back the curtain just a little bit. So our next video we have is one that is actually, doesn't need much of an introduction because it is about, and thank you both so much. Take a moment for them. That was a great hat as well. Our next video is about scorpions, so we can learn more about this little critter over there that we just got to see up close and personal. So I hope you enjoy it.
Powerful pincers, paralyzing venom, armor fortified with iron and zinc. They're totally metal. The scorpion has a fierce reputation that's lasted through the ages. Its ancestors were some of Earth's earliest predators. But this beast has a secret, a softer side. If you flip over a scorpion, don't try this at home, its belly is sensitive, and not just because its armor is thinner there. Right behind its legs, you'll see a couple of comb-like organs. These are pectins, and every scorpion has a pair. The comb teeth are covered in tiny sensors called peg sensilla. Every peg sensillum has a slit-shaped pore that takes in chemical traces from the ground and air. Each is attached to roughly a dozen nerve cells. This helps the scorpion's brain read the chemicals to understand its environment. It's similar to how we taste and smell. That's useful because even though it has many eyes, a scorpion's vision is not the best. When two scorpions meet, they use their pectins to sense each other's pheromones, invisible chemical signals they release into the world around them. This helps them determine who's a menace, a meal, or potential mate. Looks like these two are a match. They're not fighting. They're, well, holding hands and kissing, scorpion style. And this is their version of a slow dance. The male deposits a packet of sperm on the ground inside a casing called a spermatophore. She picks up what she needs. And just like that, this brief but sweet courtship is over. The peg sensilla are also sensitive to physical cues. They brush the ground as the scorpion walks, deciphering textures that help it navigate. But the pectins aren't its only specialized sensors. The scorpion's dainty feet and hairs all over its body also help it pick up minuscule vibrations. Dinner. Fossils show scorpions have existed in some form or other since before the dinosaurs. At night, researchers can find scorpions because they glow under a simple UV flashlight. Why this is a mystery. Today, there are more than 2,000 species found all over the planet. And scientists are still discovering more. There's so much pressure out there to be tough, smart, fast. Maybe the real trick to survival is cultivating your sensitive side for hundreds of millions of years.
All right, the lovely courtship dance. So to talk to us about scorpions, we have two special guests. We have Mike Seeley. He is a producer and post-production coordinator for Deep Look. He majored in biology as an undergrad at Oberlin College. Wait a sec, you're not Mike. There's Mike. This is Jacob. And he worked as a wildlife biologist on bird and seal population studies in California. He also holds an MA in documentary studies in documentary film production from Stanford University. Previous to his work on Deep Look, he worked independently for 15 years as a director, producer, and cinematographer of documentary films. And we also have Jacob Gorneau. He's a scorpion expert at the California Academy of Sciences in San Francisco. He works on scorpions and spiders. He graduated with a bachelor's in entomology from Cornell University and is currently getting his master's in biology from San Francisco State University. He is passionate about anything with an exoskeleton. But his previous and current work centers on moths and arachnids in the context of museum-based biodiversity work. So again with this, if you have any questions, write them down on the cards that you have at your disposal, and you can pass them to the center aisle, and Lance will collect them. And for those of you watching on YouTube, please put your questions in the chat. We'd love to hear from you. All right, Mike, you want to kick us off?
Sure, yeah. Thanks, Laura.
Yeah.
Well, first of all, one of the questions I had was, what makes them glow like that under UV light? And so why would they do that?
So that's a really good question, and it's the biggest answer is we don't really know. There are a couple of ideas. We think that it could have something to do with either light detection, because we have found out that they can respond to if they can tell whether they're glowing or not. But really beyond that, there's not much. Some people also think that it might just be a byproduct of their metabolism and just what happens when their exoskeleton forms and hardens. But I find that hard to believe that it would just be because of something as simple as that. I think that there's likely something else going on. But what's really cool about the fact that they can fluoresce under UV light is that it gives you an opportunity to study an arachnid in exactly how it's living. And so most of the time when you're studying arachnids or other insects, you really kind of have to dig them out of their nest or find them under and kind of take them out of their environment either by trapping or something else. But this gives us an opportunity to find them exactly where they are and to like know exactly what they're doing in that given moment that we find them. So that's the really exciting thing.
Cool. Yeah. Thanks. And how dangerous are scorpions? That's another question I have.
So this is something I really want to set the record straight on because it's really overblown in the media. They're presented as these horrifying creatures where out of the about 2,500 species described, only 25 of them are actually medically significant to humans. And so that's only like 1%. And most of those species are ones that have specifically adapted to mammal predators. And so where there aren't really that many mammal predators of scorpions, you don't really have to worry about it. All of the scorpions near and around the Bay Area are very safe. If they do sting you, it's maybe as worse as a bee sting, so not really too bad. And I've only been stung once, and I've handled almost 1,000 scorpions, I'd say. And it was definitely my fault, and I forgot about it later that evening. That's how not memorable it was. So they're really not something to worry about. Yeah.
Okay, that's a news flash for me, and hopefully probably other people out there.
Oh, actually, to that point, I'll actually say that, especially since we're finding them usually in the field at night with these black lights, we can very easily avoid them. And the biggest kind of concern are other things that you could trip over, fall over at night, or if there's like a rattlesnake that isn't going to fluoresce, or poison oak has been the bane of my existence. And so that's there are a lot of other things to worry about that aren't fluorescing that we have to avoid.
I'll take note of that. And another question.
Yeah, please. Yeah.
Okay, the dance that they do, the promenade à deux, or whatever, I think that's what people have been calling it. It's like a courtship dance.
Yeah, I'm French, but I couldn't tell you.
Okay. Well, yeah, you've got a French last name. But so tell me about that and anything else about their reproduction. It sounds they've got some secret love history that we don't know about.
Yeah, so scorpion reproduction is this really incredible thing that happens, and scorpions actually will basically they don't like inseminate like most mammals or different things like that. They do external fertilization, which means that the male will place that spermatophore stalk that you saw in the video, and right at the tip of that is going to be like a package that has all of the sperm. And basically, the male's job at that point is to basically entice the female to walk over it and take the sperm package from that little stalk. And I think that there's potentially something going on there where the female is kind of able to assess the fitness of the male because he's really kind of having to tug her over this this sperm stalk. And once he's done that, sometimes they'll also do this thing called cheliceraal kissing. So on that screen, you can kind of see there are some little like claw-like things right near their mouth, and those are called chelicera. And sometimes they'll kind of massage each other's chelicera, and sometimes the male will the male will sting the female, and sometimes he does that to kind of prevent her and kind of immobilize her a little bit from eating him, because she's absolutely willing to eat him, and it's called the male flee, and he'll run away immediately after she's taken up the sperm package. And so that's kind of the general runaround of scorpion reproduction. And then once the female has the sperm, she actually is pregnant for a decent amount of months. I was reading the other day up to like 11 months in some cases, which is a really long time, especially for an invertebrate. And then all scorpions give live birth, so you won't see any eggs or anything like that of scorpions, and they're the only group of arachnids that give live birth other than one like group of mites or something. So they're really, really unique in that respect. And then once they've been birthed, the first stage, which is called an instar, crawls onto the back of the scorpion of the mom. And basically, they just like hang out there, and she kind of guards them for that first most vulnerable stage of their lives. And they actually don't fluoresce in that situation. And
the mother one as well?
The mother will fluoresce,
Oh, okay.
but the babies won't until after their first molt. And then once they've molted for the first time, they've got to get out of there because otherwise they're a snack for mom. And so she really doesn't keep them around beyond that. And there are some social species that will hang around together beyond that, but for the most part, that's kind of a very basic crash course.
That's awesome.
Fascinating.
Yeah.
I have another question, but if
well, we have some good ones coming in from the audience, so
let's see what the audience wants to know.
Yeah.
Let's
Okay,
check
cool.
it out.
So we have a question from online from Kaiser Yuan. How good are their eyes?
That's a really good question, and we don't entirely know, but from studying, so they have two eyes like right in the middle of their cephalothorax, which you can kind of think of as their head. And those eyes, we've looked at their structures and been able to determine that they probably can actually make images from those eyes. We're not really sure like what resolution or whether it's something that is incredibly useful, but then they also have a couple of eyes around the side of their cephalothorax or their head, and those eyes are more just for light detection. And so not really like image forming, but just like whether there's light that they should either be staying away from or kind of going toward and different things like that. And so it's actually a little varied.
Wow, cool. All right, another question from online from John Paulser. Are scorpions related to ancient sea scorpions? And if you know what ancient sea scorpions are, can you just give us a briefing on that?
Yeah, I'm not super familiar with them, but basically ancient sea scorpions, they're sometimes also called eurypterids, and they were these really massive prehistoric invertebrates that would really be like, some of them would be like 8 to 12 feet tall. They're just very massive. And it was originally thought at some point that scorpions did evolve from some sort of waterborne ancestor, which is still true, but scorpions weren't like the first arachnid to kind of come on land, which was originally thought for many, many decades. So they're related, but not as closely related as like their body types might make you think.
Okay. All right, so here's a question from Josh in our audience. What animals eat scorpions?
That's a really good question. So most of the time, it's birds or small mammals will go after them. Sometimes other mammals that are like, or other invertebrates that are large enough to grab onto them. So I wouldn't be so surprised that like a tarantula or some kind of larger thing, they will actually prey on each other, even within the same species, which is pretty shocking. And
well, it sounds like the ladies are interested in eating them.
Exactly.
The males sometimes.
Yeah, and the ones that are preyed on by mammals are the ones to kind of worry about in terms of their venom potency, because they're kind of in this like evolutionary arms race going back and forth with, okay, I have the stronger defensive venom, or I'm kind of more able to eat you, and different things like that. And so that's basically that.
Okay, and then just a follow-up question. Do they taste like shrimp? No, just kidding.
You know, I have heard that they actually taste really good, but I haven't tried one yet.
Wow, nobody here has eaten the insects we're talking about. It's just so strange. Okay, so another question from online, from Thomas R. Why is it that most larger scorpions with bigger claws have weak venom, but the ones with thin claws are smaller and are smaller have more potent venom?
Yeah, so that is a really like,
true?
yeah, it's actually more or less true, and it's an interesting trend that we see, because you would kind of think, okay, they have bigger claws, they're probably like more dangerous or something like that, but the fact that they have larger claws means that they can use those claws for more things. They can use those claws more for catching food, for defense, for different things like that. And the smaller claws mean that, you know, there's less of an ability to use those claws for either defensive or predatory purposes. And so they end up developing more potent venom as a result of that.
Cool. Okay, that's very interesting.
Yeah.
Okay, so this is a question specifically for you, Jacob. Do you have any particularly noteworthy stories from collecting scorpions in the field?
That's a really good question. I think that we've been doing a lot of field work these past couple of months, and we've been going all around California, and we've encountered like pretty much every fieldwork obstacle you could imagine. I've been covered head to toe in poison oak. We've driven through very, very burned areas, kind of dodging wildfires, and we've even like almost hit a bear, different things like that. And well, we kind of hit it, but it was fun. And so I think those are some of the more interesting stories, but of the like scorpion-specific ones, I'd say sometimes the scorpions will be really high up on cliffs, and so we have like a very interesting time trying to make sure that they don't go back into their burrow, but we can still scramble up the like kind of roadside cliff or something fast enough to get to the scorpion. And so I'd say that's the most scorpion-specific interesting story we've had.
That's a good one. All right, another question from our audience. Can scorpions sense vibrations from prey or predators or mates?
Yeah, they actually rely on their vibrations a lot more than they rely on their vision. They have basically all of those hairs that you saw in the video, like all of those are like solely intended to detect vibrations. And it's even thought that those pectins that kind of come out almost like a plow or something are also somewhat mechanosensory, which means that they can detect movement and vibration and things like that. And so they basically rely almost entirely on vibration, whether it's worrying about a predator or looking for something to eat.
That's great. Cool. Well, they definitely are sensitive, as we all learned this evening. Thank you both so much, and for making this video and for being our expert on this work.
Thanks so much for having me.
Yeah.
Thanks, Laura.
Yeah, let's hear for these folks. Thank you both. Okay, so now we're going to go to yet another creepy crawly insect, an arachnid, ticks. We're going to watch this video, and we will be back to chat afterwards.
The hills are alive. With silent, waiting ticks. Their bites can transmit bacteria that cause Lyme disease and other things that can make us very sick. Protected by these palps is a menacing mouth, covered in hooks. First, she has to find a host. She can sense animals like us by the carbon dioxide we give off. She reaches out with her front legs. Scientists call this questing. It will use that claw to latch onto something, like your sleeve. Now you see her. Now you don't. Once aboard, she searches out a nice spot to bite into, for blood. She lives 3 years, but in that time, she only eats 3 meals. A tick needs enough blood to grow from larva to nymph. Nymph to adult. And then for females to lay their eggs. Gross. Let's check out a nymph, a young tick. It's tiny, smaller than a freckle. To grow into an adult, it needs 1 blood meal, a big one. The front of its body is all mouth. It digs into us using 2 sets of hooks. The hooks wriggle into the skin. They pull our flesh out of the way and push in this mouth part, the hypostome. Those hooks anchor the tick to us for the long haul, like mini harpoons. While the speedy mosquito digs in, sucks our blood, and splits, all within seconds. A tick nymph stays on for days. 3 days if we don't find it before then. Compounds in their saliva help blood pool under the surface of our skin. The nymph sips it through its mouth parts, like drinking from a straw. When a tick is full, and I mean completely full, it falls off wherever it may be. Maybe onto your bed. That's if you don't nab it first. You might have heard that you should twist or burn the tick. Not true. Grab the tick close to your skin and just pull straight out. That's how you win the fight against those tenacious hooks.
Whew. All right. This was the first video I collaborated with Deep Look on before I became the host, and I saw that scene of the enormous tick laying eggs, and I was like, you can't show that, that's too gross. And they were like, that's what our audience likes. I was like, oh, okay. All right, so to join us right now, we have Gabriela Quiros, Deep Look's coordinating producer. Gabriela has won numerous awards for her science reporting. Her video about how mosquitoes use 6 needles to suck our blood won a Webby People's Voice Award and has over 19 million views. In fact, she seems to specialize in making videos about arthropods that suck our blood. To get that footage, she sometimes sacrifices a bit of her own blood, which we'll hear more about in a minute. Gabby grew up in Costa Rica and came to the Bay Area to study documentary filmmaking. She has master's degrees in journalism and Latin American studies from the University of California, Berkeley. And we have Carrie Paget. She's the laboratory chief of the high-risk pathogens section at the California Department of Public Health in Richmond, California. She works with biologists, epidemiologists, and microbiologists to test ticks and other animals for disease-causing bacteria. She has a PhD in ecology from the University of California, Davis, specializing in parasitology. Welcome to both of you. And again, with questions, you know the drill. If you have them, write them on your card here. And then if you are in the audience, just please add them into the chat. And Gabby, I'd like to kick this off to you.
Thank you, Laura. Thank you for being here, Carrie. So a lot of people are not aware that ticks and Lyme disease are not just a problem on the East Coast, that they're also here in California. And there are studies that have shown that in some parts of Mendocino, 40% of ticks were carrying the bacteria that causes Lyme disease, and certain parts of Marin up to 20%. So can you give us some tips on how to avoid getting bitten by ticks when we're out on a hike?
I'd be glad to. So Gabrielle, you're correct. There are some hot spots where the Lyme disease bacteria, which is called Borrelia burgdorferi, is found in the tick that was featured in this film, the western black-legged tick. But on average, about 1% of the adult ticks are infected in California and about 5% of the nymphal stage of the tick. But nevertheless, there are places where the ticks have a higher risk of infection. And you should be prepared to remove a tick as soon as you find it. And to find it, you should check yourself, all your body, your nooks and crevices for at least a couple days after being in habitats that might harbor ticks. So some of the hiking areas around here in the Bay Area certainly do harbor ticks. And this species of ticks, this is filmed in Berkeley. And if you do find a tick off of you, just pull it off. You can even look while you're hiking, and I do that when I'm walking. I'll sometimes look at my back of my pant leg, because ticks like to attach they're at the ends of grass typically, and they'll attach on your pant leg or on your legs or your socks, and they want to climb upwards. So they'll climb until they hit sort of a spot that they will, be sort of safe and you won't notice them, and that's where they'll most likely embed. So you want to check yourself carefully. You also can use some repellents, such as DEET or some other repellents. If you're using DEET, which is commonly found, you should use it above 20% for ticks, so a little higher than you would use for mosquitoes. If you do go hiking, you come home and you launder your clothes. That's a really great way to make sure the ticks that are just on your clothes, you get them off before they get onto you. But if you don't want to wash them all the way, you can just put your clothes in the dryer for 10 minutes. So a hot dryer with dry clothes for 10 minutes will kill ticks.
Great, those are great tips, thanks. And so I've often heard you say that ticks that come out right at Halloween, and Halloween is coming right up. So tell us why it is that Halloween is such a landmark.
Yeah, that's just it's kind of a wonderful coincidence that a blood-sucking arthropod becomes active pretty much the same week of Halloween. I mean, we at the California Department of Public Health, one of my colleagues, Megan Saunders here, we collect ticks commonly, and we really try to find when they come out first each year, and it really is the week of Halloween. And it most likely has to do with day length and humidity. So this is when we start getting rains here in California. But even if we get rain a little earlier, we'll go out and we'll flag for ticks, and we won't get ticks. So it really is something to do with probably a combination of daylight and humidity.
And so the ones that you would see now would be the adult ones, so the red ones that we saw in the video, and then the nymphs, like this one that's up on screen, those come out typically at a different time of year, right?
Yeah, thanks, Gabriella. So that's exactly right. So this is the time of year to be most aware of the adult stage, and the adult Western black-legged tick will be active through the time of year it starts to get hotter and drier here. So roughly around May. And then the nymphal stage will become active around March and be active through June, typically. There's, some fluctuations there. But, and I don't know if people had an opportunity that are here in the audience to go and look at some ticks, but the red tick is just the female stage, so that if you find one that's all black, that's the male tick of that same species.
Can you remind us can you demonstrate for us again what the best way to remove a tick is?
Yes, so I get asked a lot of how do you remove ticks? Here, I brought some of my my.
Can I hold your microphone for you?
Sure. So I want to first say some ways not to remove ticks. So don't fall for putting Vaseline, mayonnaise, soft soap, fingernail polish, all sorts of things to just smother the tick and then have it, crawl out on the, the cotton swab that you put the soft soap on. That's one, it doesn't work. But if, some crazy fluke chance it did, you don't want to delay. You want to get the tick out right away. So to remove a tick, so the tick, you saw the picture, actually it's right above us. So if the tick is embedded into you, you want to just simply put forceps right down, or tweezers, just down at the bottom and pull straight up. Don't twist it. You don't have to worry it in any way. Just pull straight out, and the tick should just come straight out. And I think we were just talking that you successfully removed a tick this way for your friend, and she was very impressed with you. So
yes, it's a great party trick if you're out on a hike. And I was with somebody who had one attached to them, and I had just finished the video, and I said, does anybody have some tweezers? And just did exactly what you just did, put them really close to the skin and pulled straight up, and it came right out. It was impressive. It works really well. And I wanted to ask you, a lot of people have seen the video online, and there have been a number of misconceptions that people have written in the comments. One of them is, don't pull the tick out because it could vomit inside you. So what do you think is at the core of that? And what would you say to people who are kind of afraid of removing them or removing them incorrectly?
Yeah, that question or that comment about vomiting is something that really does not happen. So, there should be no fear about, squeezing the tick and worrying about, having it, basically like everything release into it. So the tick is embedded and it does release, sort of salivary glands. It does have anticoagulant properties that are, will secrete into you. But the faster you remove the tick, the faster that, it can transmit any disease. So for Lyme disease, it takes a minimum of 24 hours to transmit from the midgut into a person. So if you have a tick on you and you remove it within 24 hours, your risk of Lyme disease, acquiring Lyme disease is pretty much nil. So, the message is to remove the tick as soon as you find it. And if you don't have tweezers, you can always take Kleenex and pull straight up. And if you do that and you're not using forceps, and you might leave a little bit of the mouth parts into you, that is not going to transmit any disease to you. The mouth parts themselves may be just a little dirty because they're in nature, and you might end up getting a little irritation at that site. So removing the tick, cleaning it with soap and water, using maybe Neosporin or alcohol to clean it. I know we all have hand sanitizer ready. That works great too. And so, it may, as I said, the mouth parts might be embedded, but they'll work their way out just like a splinter would.
Fantastic. That's so great to know, because I know that people do worry about parts staying inside. Thanks.
Yeah, that's a lot of great info. Okay, so we've got a question a few times, and I think, Gabby, you might be the person to answer this one. Was that tick actually on someone's skin in the video? If so, whose?
Yes, it was. And it wasn't me. But Carrie and I did spend an afternoon in my house trying to get bitten by ticks so that we could film them. And it didn't work. So it turns out that we're not attractive to ticks, which is a good thing. But Ariel Cruz was the person, fortunate or unfortunate, who they did bite into. That's her skin. And at the time, she was a student at San Francisco State University. And actually, Carrie, she worked for you afterwards. So that's whose skin it is. And then there is the skin of different volunteers being crawled on by ticks.
Wow. How can I sign up for that gig? Just kidding. Okay, so we have another question from online. This is from 3 Turtles, 1 Shell. What makes ticks such a good host for so many different types of disease-causing bacteria?
Well, one aspect of ticks is that they are unlike some other blood-sucking arthropods in that they stay attached for a long time. So, this aspect I mentioned about having to take some time for the Lyme disease bacteria to transmit. I mean, if a tick only fed for a short amount of time, it would not be able to transmit. So they are kind of unique in that there are some tick species, soft ticks, that can feed very quickly. And they do, some of those species do transmit diseases, but the diversity of those diseases might be a little bit smaller. So I think that's probably kind of one of the best reasons is that they're, they stay on you for quite a long time. So it might take for an adult tick, 3 or 4 or 5 days to feed to what you call repletion until it is full of blood. It can take up to 100 times its weight in blood, which is amazing, and then will fall off. So it's crazy.
All right, this question is from Marcos from online. How long can ticks live without eating?
So I mentioned soft ticks. There are some soft ticks that can live for decades in crevices in some areas of the world. So those ticks are a little special. So the Western blacklegged tick, I actually did this was my first scientific publication where we figured out the life cycle of this tick. And I took ticks and put them in little silkscreen tea bags, and I put them out in nature and checked them every 2 weeks, different life stages, and we found that it took 3 years for the tick in California to go through its life cycle. So for the life cycle, that's how long. For an individual stage in that life cycle of the Western black-legged tick, it's about a year.
And so it could go without eating for that whole time or for the years?
It can go for a year and then it will die here in California most likely because, where we are, it's very hot and dry. I think when back east, the life cycle is a little longer. It can be about 4 years.
Wow. And so they basically eat a big meal to molt and grow from one stage to the next, from life stage to the next, and they have, 4 life stages?
Yes, yeah. So they start out as an egg, then they develop into a larvae. Here in California, they hatch around July, which is interesting, and then they wait in this sort of diapause until basically the spring, and then they feed as a larva on, here in California, they feed on lizards, and they also feed on rodents, and then that will kind of wait another year and then molt, and then yes, you're right, that once the adult stage feeds, they need that blood meal, the female needs the blood meal to make eggs. The male tick it may take a blood meal, but a very small blood meal, so the potential of the male Western black-legged tick as a disease vector is very muted.
The whole blood meal phrasing is really unappetizing. This is a great question from Wade. What's the best way to discourage ticks around the home and on pets?
Around the home, if you live in kind of a rural habitat, making sure that you clear brush and keep log piles away from your house. These are all kind of standard recommendations for the Western black-legged tick, or in the East Coast, the black-legged tick. You can also use like cedar chips. That's a very good habitat that ticks are not going to do very well on. These ticks don't do great on lawns necessarily, but wild grass. If your lawn gets a little crazy, that's great habitat for ticks. And most in the home, these ticks are not, they don't go through their life cycle inside. There is one tick species, the brown dog tick, that will go through a life cycle, can live inside your homes. So that's a good reason that you have your dog on, tick and flea control. But this tick does not, you do not have to worry about it, finding it in home, unless your dog brought it in and laid on your couch and then you got a tick on you that way, which is totally, a possibility.
Okay, well, those are some helpful tips. Another question is looking at the positive side of things. Do ticks contribute anything positive to the ecosystem?
I was just saying that I get asked this a lot from like Boy Scouts, and it's a hard question to answer because it's really nice to know people ask this, as thinking about our ecosystem. The idea that they do transmit diseases, they certainly do have a contribution. It may not be what we think is a positive contribution, but yeah, I don't think it's probably very subtle that their contribution. I don't know if ticks disappeared, if we would, as humans, notice it. But there obviously are some animals that do feed on ticks on animals, so they would probably have to find an alternate food. But that's a great question.
Yeah. Okay. Well, thank you.
Possums. Possums eat ticks. So, but are you going to be sad if possums can't eat ticks anymore? Maybe not.
How do you really feel? Well, thank you both so much. We have plenty more questions, so hopefully we can answer some of those in the chat online later. But this is definitely a fruitful topic. Thank you both thanks for making the video, and thanks so much for providing all the expertise. Let's hear for these two, Gabby and Carrie.
Thank you.
Thanks. All right, so we are going to watch one more bonus video. It is all about pallid bats, and we won't be doing a Q&A after this video. So if you have questions, you can hold them for the exhibit hall, where you can meet Corky Quirk, founder of NorCal Bats, a Sacramento-based organization focused on rehabilitating bats, and ask your questions in person. And for those of you watching online, we'll do our best to answer your questions in the comments section. All right, let's see this last video.
Slicing through the shadows, scanning for prey hidden under a cloak of darkness. Bats are masters of the night sky, thanks to their twin superpowers, flight and echolocation, using sound waves to find prey. So, what the heck is this one doing? It's hunting on the ground and not flying. Kind of an undignified way to catch a meal, isn't it? I mean, for a bat. Turns out echolocation, that natural sonar bats use, isn't the killer technique you'd think. Like, it's not actually that sneaky. We can't hear the frequency that bats put out, but to a moth, it's louder than a scream. More like a jet taking off. It's kind of a dead giveaway. And some prey have found ways to fight back. This tiger moth is loaded up on a diet of toxic plants that make him disgusting to eat. A fact he broadcasts with warning clicks from an organ called a timbal. The same one cicadas used to sing. Bats learn as pups to stay away. And these hawk moths can scramble bat sonar by emitting clicks from their genitals. It's a dogfight that bats are starting to lose. That's why some, like this pallid bat, are changing the game. She still echolocates, but only to navigate. And she keeps the volume low. She's a whispering bat. When it's time to hunt, she goes into stealth mode. Her ears point down, where scorpions and crickets are milling in the loose earth. And she listens. Look at those ears again. They're huge relative to her tiny skull. They do a great job of capturing and amplifying sound, especially the low-pitched noises of scurrying prey. And see that funny flap? It's called the tragus. They provide extra information about where a sound is coming from. We have them too, but in a bat, they're way bigger. And the bat has a final card to play here. She's immune to scorpion venom. But the sting rattles her a little. It's not as graceful as the high-flying aerobatics, but hey, it works.
They are so cute. I really hope you get to go and enjoy and check out some of those awesome bats out there in our lobby after the show. We hope you enjoyed being here. Thank you so much for welcoming us back to the space, and we're so glad that you could all join us here at KQED. For folks here in person, yes, please be sure to go to the lobby and check out not only those bats, but Carrie Paget with ticks, and Jacob Gorneau and Trent Pearce with a scorpion, a black widow, and tarantulas, and Corky Quirk with the bats. For those watching online, we're going to drop a link to our Creepy Crawly playlist if you want to watch more A special thanks to our experts and our Deep Look producers, Josh Cassidy, Gabriela Quiros, and Mike Seeley for their time tonight and for helping us to answer all your questions. Also, thanks to Corky Quirk of NorCal Bats for being here. And a special shout out to Deep Look's production team. Craig Rosa is our series producer. Each episode has an original score by Seth Samuel, and additional editing and motion graphics are by Kia Simon. And many episodes, like the Ticks and the Bats episode you just saw, include special animations by Tedros Hialeah. I co-write and host the episodes. It definitely takes a village to produce Deep Look. Please do subscribe to our YouTube channel, KQED Deep Look, or watch our videos at kqed.org/deeplook, and consider supporting Deep Look via patreon.com/deeplook so we can continue bringing you these incredible videos. Mark your calendars for our next video on November 9th, all about kissing bugs. They are these big insects with a long head, and they feed on your blood and pass on a parasite that can be deadly. And if you guessed if Gabby made that video, you would be correct. For those of you watching on YouTube, thanks again, and look for photos from tonight's creature exhibits on our community tab. We will see you next time. For those of you here, let's all creep over to our lobby to see some bats and scorpions and spiders and ticks in person. Happy Halloween, everybody. Thanks for coming.